All right, so I'm going to give you a really basic introduction of how volume works. So what we're looking at here is a wonderful plain piece of white paper. There's just one of them. Now, technically, this piece of paper is a rectangular prism because it has a length, a width, and a height. But when I look at this paper, it's so thin that I almost can't even tell that it has a thickness to it. It's so thin, right? So really, we almost think of this piece of paper more as a two-dimensional shape rather than a three-dimensional shape because it's so thin. So I could find the area of this piece of paper, okay? And so the way I want you to think of volume is it's like taking this base area, so this is a rectangle, and the way I'm going to get volume is by continually stacking the same rectangle on top of itself over and over and over. So right now, this rectangle, as I said, there's like no thickness to it, right? It's just basically this flimsy little rectangle that kind of exists in two dimensions. It basically doesn't have any thickness to it. Now, as I move over, this stack now has 5 sheets of paper in it. So this stack has gotten a little bit thicker. If I was to tip it up like this, we can see now that there actually is a little bit of a thickness to it. Kind of hard to see, but you can see there is some depth to this stack. So now that I've put 5 rectangles on top of one another, I'm starting to see some thickness. So if I kind of look from the side, here's my first one. There's like no thickness to this. There's no depth. Right? There's no height. As I move over to the one with 5 sheets, I can see that it's getting a little bit thicker. It's kind of actually off the table a little bit, right? Well, now I'm going to move to my stack of 10. So again, still the same base rectangle shape, but now I've put 10 sheets of paper on top of one another. And again, this one is even thicker than it was before. So as I keep placing sheets of paper on top of themselves. So here was the 5 stack, and that corner is kind of bent, but there's the 5 stack compared with the 10 stack. It's getting a little bit taller, okay? Well, what if I was to keep adding this rectangle on top of itself more and more and more? As I move over now, here's what it looks like when 50 of those sheets of paper or 50 of those rectangles are stacked on top of one another. So now I'm getting some height to my rectangular prism. When I'm talking about volume, our basic definition for volume is we take the area. I'm just going to move this one because we can see through. I'm just using recycled paper because it's good to use recycled paper. So if I take this one here, I still have this base area, which was my rectangle. So if I take that base area and I multiply it now by the height, that's going to give me my volume. And so what you think of for volume is it's basically that same two-dimensional shape is stacked on top of itself over and over and over again until the stack eventually grows taller. Okay, so the volume, our basic formula for volume is the area of the base, so in this case our rectangle, times how tall it is. Or essentially thinking how many times we're stacking that shape on top of one another. So sheets of paper are really, really thin, right? As I add more and more together, I get a bigger and bigger rectangular prism. What happens if I stack 2,000 sheets of paper on top of one another? Now I have a real height to my rectangular prism. It still is. Now I had to leave it in the wrapper so that I didn't get in trouble from my secretary. I still have that same rectangle area, but now I have a really significant height. Okay? So the way we would find volume of a rectangular prism, or the way we find volume of any shape, is by knowing the area of its base, in this case the rectangle, and we multiply by how tall the three-dimensional shape is. And I'll show you some examples in the next video.